Hi all, welcome to another PYQ discussion. Let's move into the class. The first question is the number of position integers not exceeding 100 that are either odd or the square of an integer is. This is today some of the maths questions I am going to discuss. Apart from that, some other subject also included. Okay, first look into this first question. Actually, this is the question coming from the topic principle of inclusion and exclusion theory. Okay, first look into the what is principle of inclusion and exclusion theory. We should have an idea. That is somehow if we have a two arbitrary set. Here they have given two types of condition that the number of position integers not exceeding 100 that are either odd or the square of an integer. Two conditions they have given either odd or the square of an integer. Okay, so here two sets we need to consider. According to that, as per principle of inclusion and exclusion theory, for two arbitrary set A and B, we have to find out A union B, the number of elements in A union B we have to find out. For that we have an equation, number of elements in A plus number of elements in B minus number of elements in A intersection B. So based on this equation, we are going to do this question. Okay, you should thoroughly learn this equation. This is very, very important. So the first sentence, what we have to find out, they have given the range, that is 100 is the range. In that we have to find out how many numbers are odd. First we have to find out how many numbers are odd. So we know that numbers 1 to 100, the half of the numbers are even and half of the numbers are odd. So from that we will get number of elements A is equal to 50 we will get. Okay. Then number of squares. Second condition is what? The second condition they have mentioned the square of an integer. Square of an integer means if we take a number 1, 1 square is 1, 2 square is 4, 3 square is 9. Up to we are considering 10 square is 100. But if we are taking 11 square, it is exceeding the range. Is it? 11 square is equal to 121. So we can't consider that number. So total 10 digits we will get. That is number of elements in B is equal to 10. Next we have to find out both the condition. That is A intersection B we have to find out. Number of odd number and square is equal. Both the condition they should satisfy. Those kinds of numbers we should taken from these two sets. So 1, 9, 25, 49, 81. These are the numbers we are getting A intersection B. That is 1. 1 is an odd number and also it is a square number. 1 square is equal to 1. Next 9. 4 we can't take because it is in the even number. Okay. Next 9. 9 is an odd number and it is the square of 3. 3 square is equal to 9. That is also a square number. Next 5. 5 is also a square and it is an odd number. Likewise, we will get 5 digits as A intersection B. Next, now we have to find out either odd or the square. We will get how A union B or condition A or B. That is union B is equal to 50 plus 10. That is A number of elements in A plus number of elements in B minus A intersection B is equal to 5. So we will get the answer 55. Okay. Next, move into this one more equation we have, that is if we have considered three set we have to use this formula, that is number of elements in A plus number of elements in B plus number of elements in C minus A intersection B minus A intersection C minus B intersection C plus A intersection B intersection C. This formula is also very important. These two equation you should study for the questions from principle of inclusion exclusion coming. You can use this type of equation. Okay, so the first question answer is 55. That is option C. Okay, let's move into another question. How many ways are there to pack six copies of the same book into four identical boxes, where a box can contain as many as six books? That is, they are giving that one book copy, six copies we have to pack. We have four boxes. We have to arrange these books in these four boxes. How many ways we can arrange these books? Let's look into the arrangement. That is six copies of the same book. So total we have six books. Okay, in the first arrangement we can put six in one box. Other three boxes we can kept it as empty. Okay, next is one box we can fill it five books, another book one. So and other two boxes empty. Here four two, then two boxes empty. Again four one one 0, 3 3 0 0, 3 2 1 0, 3 1 1 1, triple two 0, double two 1 1. These are the nine ways we can arrange the six books in four boxes. Okay, this is very simple question. You just simply draw four boxes. If one box you put four boxes, you have simply draw. Okay, you have four boxes. In this, if we put six in this number, then another there is no other books to book put in boxes. So these three boxes will be empty. Again, we can split this. We can't split the six. Again, next step, what can we arrange? The five with the five. If we are putting five maximum in one box, then remaining one book we can put in another box. Again, we are maximum we are putting four in one box. Next two we can put in one box. Okay. Likewise, these nine ways we can arrange. This is the second question. The second question answer is nine ways we can arrange the six identical six copies of a book. Okay. Next question is this question is from propositional logic, and four statements they have given. Not these here comparison is doing not logically equivalent. Which of the following pairs of propositions are not logically equivalent? We have to find out which are the pairs not equal. Okay, for that we have to know some truth tables, propositional logic. Okay, the first checking the equivalence of first statement. P implies R and Q implies R and P or Q implies R. This is the statement they have given. We have to find out these both the statements are true or false. Okay, equal or not. First, P implies R. First, we have to write the truth table where we have three variables P, Q, R. This is based on the values. That is, we know that zero truth table in digital logic we have write the truth table 0 0 0. If three variable, we will get uh, eight eight combination of values. Two cube is equal to 8. So three variables also we will get eight values we will get. That is one. All the three variables are true and all the three variables are false. Then here drawing option is there. How? See here, actually these values are based on, the 0 0 0 0 0 0 1 0 0 1 1, like 1 0 0 1 0 1 1 1 0 1 1 1. These are the values we will get based on the truth values. So whole zero, that is full variables are false. Then P implies Q. What is the result we'll get? P implies R. We are taking this P and this R. P implies R means whenever the P is true, that is uh, uh, only one condition, except one condition, all other conditions will be true. Only one condition, except one condition. That one condition is 1 0 case. When P is false, P is true, R is false. That kind of TF, the I will write here. P implies Q, P implies Q, or P implies R. The result of this is when P value 1 and R value 0. During that condition only, it will result 0. That is false value. False value it will return. 1 0 case. Otherwise, all other remaining, when both are true, both both are false, and P is false, R is the second values, P implies Q or P implies R. These three values gives the result true. Okay, this is the truth table of P implies Q. Only one condition you should remember, that P implies R when it will give the false result when the P value is false, true, and R value is false. 1 0 condition, that is 10. You should remember 10 is equal to 0. 10 value wherever true false condition wherever it is coming, there all the values should be false. Where are you can see where which are the places you can see the TF value, that is TF, only TF gives the this is TF gives the false value. TF equal to F. This is P implies R. This only you should remember, TF is equal to false. So here one T, here one T. P implies R. How we can draw? T T. T T means T. True. True, false. False. That is TF. I told you that true false condition only gives false result in the P implies Q equation. So here also T, both are true, true, no issue. Here also T true and false coming, again false came. Here false, true, true. False, false, true. False, true, true. False, false, true. So P implies R we get. Okay. Likewise Q also the same manner. This based on this truth table we are writing these values. And we have to do AND operation with the P implies R and Q implies R. AND operations means when both the values are true, during that case only we will get true value. Here one both this and this value is true. Here both T is true and here both are true. So true. Here both last two column, last two rows true. So this table is we are getting these values. Then we have to find out P or Q implies R. So first we have to find out P or Q value. P or Q. P or Q means whenever P is true, any two, any one of the value is true, we will get the result true. Any one of the result is true, we will get the result also true. This here first four rows are getting true values, and again here next two rows, the Q value are true. So next two also true, but the remaining last two rows are giving false result. So P or Q gives this truth values. Next P or Q implies R we have to find out. We already got P or Q value. With this we have to compare the R column R. So whenever P implies R, P implies R, here you can see the truth values. When only the value is false, wherever the condition true and false will come, there the result is false. So we have to find out the TF first, T true and false condition. Here both are true, so true. Here true and here false, so false. Here true, true, and here true, the R value false, so TF condition came so false. So likewise this column we will get. So as you can check that these column, that is P or Q implies R and P implies R and Q implies R are getting the same truth value. So these statement both are logically equivalent actually. Okay. I hope this is clear. Next, we are moving into the next statement, that is P by implication Q and negation of P by implication negation of Q. This is logically equal or not, we can easily find out. P and Q values we have written, that is true, 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 false, false, true, false, false. This is what the truth values of P and Q. Negation of P means its opposite value. If P is true, negation P means false. So wherever true, its opposite value we have written in negation of P column. Likewise, negation of Q we have find out. P by implication Q means whenever the both values P by implication Q, that is the truth value of P by implication Q means wherever the both the values are true, that is true and Q true, then we will get the result true. And wherever both the values are same, P value false and Q value false, then we will get the result true. These two statements you should remember. Wherever the truth values of P and Q are same, there we will get truth value. Others are false. Okay, this is actually the equation of this condition is also similar in digital electronics, that is XNOR gate. So that XNOR gate you should remember, then you can easily find out the truth values of P by implication Q. P by implication Q truth value we will get T truth, false, false, true. Next, negation of P by implication negation of Q means same, where we already find out these two tables. So wherever the same value coming, these both are same value, false, false. So there we will put true. Here also both are same, so true. So these two columns are equal. So from this truth table, we can conclude that these statements are equal. Okay. Next, that is by implications other equivalent equations, that is P by implication Q is equal to P implies Q and Q implies P. This is one standard definition of by implication. Another equation is P by implication Q is equal to negation of P and negation of Q and negation of P and Q, or P and Q. Here or condition, here and condition, but here one negations are included. Okay. Next, P implies Q is equal to negation of P XOR Q. That is that is what XNOR gate. This is XOR negation of XOR gate means XNOR gate. These are the three definition of by implication. Next, checking the equivalence of P implies Q and Q implies P and P by implication Q. This term this is actually one of the definition of P by implication Q. We have learned That is P by implication. Q means what? P implies Q and Q implies P. Okay. So third statement is also true. The fourth statement is not equivalent. As per this truth table, you can see that P and Q implies R values are these. We will get, but P implies R and Q implies R, we are getting these values. So these two columns are not equal. So we can state that these two statements are not logically equivalent. So option 4 is wrong. Okay, I hope this is clear. These are the revision table. You can easily, that is the what is proposition? What is proposition means a declarative statement that is either true or false. Proposition means what? Oh, a statement that is either true or false. So the sky is blue. This is true. Actually, this is true. Is it the sky is blue? It's true. Blue. Next, logical equivalence. Two proposition with the same truth values for all possible assignments. So, logical equivalence means what? Two propositions with the same truth values for all possible assignments. That is, P implies Q means the statements you should study negation of P or Q. Next, implication. That is, this is what P implies Q is false. When will implication false? Only when P is true and Q is false. This condition I told that TF condition. That if it rains, then the ground is wet. That is P when P is true, but Q is false. Then only not the always not true. Okay. Conjunction P and Q, the symbol conjunction is, and this is the symbol of conjunction, and P and Q or P conjunction Q is true only when both the P and Q are true. That is, it is raining and it is cold. That is, both the statements are true. Disjunction means or condition. P or Q is true when P is true or Q is true, or both are true. We know that you can have tea or coffee. Okay. The biconditional, that is P implies Q is true when P and Q have the same truth value that I have already mentioned. I will go if and only if you go. Next, De Morgan's law, rules for negating conjunction and disjunction. This is one of the negation and conjunction and disjunction operations. How De Morgan's law work? Negation of P and Q means negation of P or negation of Q. Negation of P or Q means negation of P and negation of Q. Okay, next. Moving to next question. This is from computer organization. Consider a machine with a byte addressable main memory of 2 raised to 16 bytes and a block size of 8 bytes. Assume that a direct mapped cache consisting of 32 lines used with this machine. How many bits will be there in tag, line, and the word field of format main memory address? That is, here we have to find 3 bit, we have 3 column actually. We have to find out these field, tag field, line field, and word field. That is instruction format. We have 3 columns we have, 3 field we have to fill. Okay, 1, 2, 3. 3 column we need to uh, find out. The machine with the byte addressable main memory is byte addressable, that is 2 raised to, total is 2 raised byte addressable memory. How to draw? 2 raised to 16 they have given. Is it 2 raised to 16 they have given? So the total memory size is this 16 bit. You have to take the power. This is considered as 16 bit. The total bit is 16. Okay, 16. 16 we have. If this 16 bit we have to assign these three field, that is tag field. First one is tag field, the second is line, and the third field is word field. We have to find how many bits each carry. So that for that, here they have given 32 lines. Okay, 32 lines means we have to find out the line field here. This field we can find out easily. That is 32 lines. 32 lines means how we can write this 32 in the power of 2. 2 raised to 5 is actually 2 raised to 5 is, see, 2 raised to 2 raised to 5 is equal to 32 bit, we know. Is it? This 32 bit is considered as, this 32 bit is considered as 2 raised to 5. So this 5 bit we can consider for this index field, okay, or the line field. Here we can say that this is 5 bit. This is 5 bit. Okay, can't see. 5 bit. This line bit is 5. Next, we have now that 16, that is total, and this is 5 bit, and any other information given, that is block size of 8 bytes. That is block size means this memory main word field, that is 8 bytes they have given. Block size means 8 bit they have given. So 8 bit, how we can, 8 byte is equal to 8 bytes equal to, we can say that 2 power, in the 2 power 3. So 3 bit is used for, 3 bit is used for that word field. Okay, word field. So here we will get 3 bit. This is, 3 bit. So this is 3 and this is 5. So total 8. Total bit we have 16. So 16 minus 8 is equal to 8. So this word field is 3. This line field is 5, and this first tag field is 8. How we will get the 8? 16 minus 8 is equal to 8. The detailed explanation I have given in next slide. See, we can byte addressable memory. So these are the data given in the question. 2 raised to 16 bytes, block size 8 bytes. So direct mapped cache with 32 lines they have given. So from 32 lines we will get block, here block offset, that is byte number, 3 bits to represent the byte number, that is memory. We will block offset, we find out that 2 raised to 8 is equal to 3 bit. Line index 2 raised to that 32 bit, 2 raised to the 32 bit, we can write it as 5 bits, that is line index. Tag bit also we find that a 16 minus 3 minus 5, 8 bits. From this, the answer is 853. Option A is the answer. Next, here one instruction given, instruction code given by microprocessor instruction. What is the final output of this instruction code? Okay, let's check each and every sentence. First, they have given some instruction that numbers 210, that is address field. Then this is the instruction we have to do. CLA means clear clean accumulator. Okay, what clean accumulator, that a CLA means. So set to 0. Then 211. 211 means add a content of location 217, comma 1234 hexadecimal to accumulator. That is content of 217 we have to add. Where is 217 is locating? Here. Here you can see the 217. Here 1234 is given. So add this 1234 to accumulator. Okay. Then increment accumulator by 1. So value of 1, 2, 3, 4, 3, 4 become 1, 2, 3, 5 actually increment after increment. Then next instruction is store 217. 217 means that is 217 value means 1, 2, 3, 4 that is incremented. So 1, 2, 3, 5 is stored. Next load 218. 218 what is the value of 289 CE2H. So this value is stored in 218, that is load accumulator with the content of 218. So accumulator now the value of accumulator is 9CE2H. Next complement the accumulator. So accumulator now have 631DH. How we can do the complement? Here 9CE2 is written in binary. How the two values 0, 0, 1, 0, E is 1110, then C value is 1100, and 9 is 1001. It's one, it's complement. It's complement we are doing. It's if wherever 0 it will be 1. 1 becomes 0, 0 become 1. So this value become this 0110 0011 0001 1101. It becomes we will get 631D. Okay, this 631D is we have to AND with next operation and 217 perform bitwise AND. So 631D and 1235 we should AND. We AND means we should take this binary value and find out the 1235 binary value. Do the AND operation, we will get 0 to 1 5. Answer is 0 to 1 5. AND operation want to do means here how I can draw. See, I will show how to do the AND operation. See the values of 631D is it which is equal to 1, sorry, and value 6, value of 6 is what? 1 0 0 1. Sorry, 0 1 1. 0 is value of 6. 3 means 0 0 1 1. 1 means 0 0 0 1, and the value of D is 1 1 0 1. Next, we have to AND with the 0 to 1 5. Okay, its binary is 0, sorry, 0 to 1 5 not 1 2 3 5. This is the hexadecimal value we in the accumulator. We have to AND with this. 1 means what? 0 0 0 1. 2 means 0 0 1 0. 3 means 0 0 1 1. Okay, next 5. 5 value 0 1 0 1. This is when while doing AND operation what will get? Here wherever the similar you can do from here. Similar values only, that is wherever both are true only we will get true value. AND operation 1, here 0, sorry I can write Here 0, both are 0, 0, 0, 0, 0, 0, 4, 0 we will get here. Okay. First is 4. Next, here, what is the result? Both are 0, so 0, both are 0, 0, then both are 1, 1, 0. Next is 0. Here, 0, 0, 0, and 1. Next, 0, 1, 0, 1. So, what is these digits in hexadecimal? What is the value of both are 0 means 0. Next is 0, 0, 1, 0 means 2. That is, this is the value of in decimal value 2. Next, 1, 0, 0, 1, 1 means 1. 0, 0, 0, 0, 1, 0, 1 means 5. This is the result we will get 0 to 1, 5. I hope this is clear for you, and thank you for watching this class.